Hey, what's up guys? Back again with another video in the Java series. This time I'm going to teach you about the basics of reflection. So reflection is a topic that has been requested many times on my channel and I never got around to it, but I thought today I would show you the basics of reflection and how you can use it within your programs. So what is reflection? That's the essential question here. So in simple words, it allows you to grab information on a class whenever you're running the program from within the program using code. And this cannot be done with other programming languages, so it's a unique feature to Java. I mean, there is other programming languages that can do it, I'm sure, but before Java, this was a very unique feature. This cannot be done in major programming languages like C++ and C and all that. So yeah, I'm going to show you the basics to get started here. I'm not going to show you everything in this episode, but I will get to showing you some more advanced stuff with reflection. I just want to show you some basics on how you can start understanding it and using it within your code, okay? So first things first, the essential building block of reflection within a Java program is the class reference. So this would be a class reference here. So it's a reference variable that is called a class. That's the type. So this is what you use reflection upon. So let's say that we want to get the class reference for a integer. So we need to give it a name just like any old reference variable is equal to, and then integer dot class. That's one way to do it. So that's basically a class reference for a primitive integer, and we can grab information from that class reference now that we have it. So we can do c1 dot, and we have all this information here available to us to grab. So let's just try printing out something very simple like get name. So let's make a new output statement, sout get name. There we go. So that should print out the name of whatever this reference represents. So let's run this and see what happens. So there we go, we get integer into the console because this is indeed a integer. So that's how you get a class reference for a primitive type. So let's say that you want to do it for a double. You can do class c2 is equal to double.class. You can do class c3 is equal to long.class. Class c4 is equal to null.class. You can even do null, right? Or no, maybe not. Oh, void, it was void. You can do void.class. So that's how you get the class reference for any primitive that you might come across. And so this is not too useful, at least at the moment, for primitives, but how can you get the class reference for some other types? So let's say that you have a object. So let's go ahead and create an object within our project here that we can work with for testing this new stuff. So we're going to make a dog class. So what is our dog going to have? Let's have some just very basic stuff. So private string name, private integer age. Let's do public. So we're going to need a constructor. So public dog, and this will be a no argument constructor. So by default, the name of the dog will be Bob, because, you know, any good old dog's name should be Bob by default. And the age will be 2 years old. So public dog, and this will be a constructor that has arguments. So string name, integer age. So this dot name is equal to name. This dot age is equal to age. So this is very basic, simple stuff. So then we'll do public. We'll just make some getters, getters and setters for our members here, the name and the age members or fields, whatever you want to call them. So getter and setter, boom, and now we generate the four methods for these things here. There we go. And what's the problem? Okay, we can ignore that. That's fine. So anyway, so how can we get a class reference for the dog class? So we can do class C, I guess we'll call it dog class. That's a better name. So the class dog class is equal to dog.class, just like we would do with the primitive. So that's how you get the class reference for a dog type, because our class here technically is a custom data type that we have just invented technically, right? Anyway, so now that we have that, like before, we can grab information from it now. So dog class dot get name, and it should print out dog. Let's see what we get. There we go. So we get me.codysimpson.dog, which is just the package name in front of it, and then the class name itself. Pretty cool. So let's see what other information we can grab from this. So sout dog class dot. So there's a lot of information we can grab from this. We can get the constructors of this class. We can get the fields of this class. We can get the methods of this class. So as you can see here, reflection allows you to get the detailed information of a class from within the code itself. So basically the code is getting information on itself, which is kind of a cool concept if you think about it. So think about the possibilities here. What is really possible with this? So let's say that you have a library that you're using within your application or you're interacting with, and you don't really know information about it until you're running the program. Let's just say that, right? So what you can do here is use reflection to get information on that library that you're using at runtime. So you can start using it. You can even call the methods of the library if you want to, using reflection instead of, like you would normally do with any normal old class. So you may ask, why is this really useful? Because we can just, declare objects like we would normally do within code. Why would that be useful if we can just do it with, normal objects? So what makes this truly powerful is that you can access private members, private fields of the classes that you're interacting with. You can access all the intricate details of a class from a library or just anything, right? So you don't have to worry about being restricted. You can actually look at it at runtime and then use it if you want to. So it allows you to do some pretty cool stuff. So one example is making a JSON to Java like translator. You're converting JSON text into Java classes basically, and the other way around too. That's one example of Java reflection. And there's some others, like for my Spigot series, I think I said this already. You can use reflection to have multi-version support. I'll leave some interesting resources in the description below so you can see some more information on this if you're truly curious, if you want to. But yeah, besides that, just to recap, basically you can use reflection to access the intricate details of a class and its objects and all that stuff, and even interfaces, anything, right? So it's really, really powerful. So again, this is how you access the class reference for a undeclared dog class. So you haven't made an object of dog yet, you're just accessing it by calling the dog class thingy here. That's one way to do it. And so another way is, let's say you do have a dog instance, or an object as you might call it. You can do dog is equal to new dog, Bob, and he's 4 years old. There we go. So now we have a new dog object, and so now we can get a class reference of that. We'll call it dog class again, is equal to, instead of doing, we could again do dog.class, but since we have an object here, we can use it. So dog.getClass, and that's one way to do it. You can call the getClass method, and that returns a class reference to the class that you, to the object that you have here, okay? So hopefully that makes sense. It's literally the same thing, except that you're calling it, or you're accessing it a different way. So now that we have that, we can access information on it like we were doing a second ago. So we can, again, print out the class name, dog class, dot get name. And there's also some other basic methods we can use to grab some basic information on a class reference here. So interface. So we can do dog class dot is interface, and that returns obviously if it's an interface or not. So you can get a class reference for a interface if we have one. So yep. So s out. So hopefully you know this already. A array is technically like a class behind the scenes. So we can do is array, and that will tell you if it's an array or not, an array type. So let's try diving deeper into this class that we have access to. Let's try accessing the constructors of this class. So we can do dog class dot get constructors, and that will obviously return the constructors of the class. So it says returns an array containing constructor objects reflecting all the public constructors of the class represented by this class object. An array of length 0 is returned if this class has no public constructors, or if the class is an array class, or if the class reflects a primitive type or void. So that's some good information that we could use. So we know here that this class does have some constructors, so we don't have to worry about checking to see if it returns 0 or not. So we can now go back here. If we do Control Q, it says it returns an array of constructors here. So we can make an array of constructors to store that in. So array of constructor array, we'll call it constructors, is equal to dog class dot get constructors. So now we have a new constructors array. Make sure you import constructor from the reflection package. By the way, that's in java.lang.reflect. That's where you find all the reflection stuff there, okay? If you want to check out the documentation. So yeah, now we have an array of constructors here, so we can, just like we're doing with the class reference here, we can use the constructor references to grab information on the constructors of the class. So let's loop through this. So for constructor, constructors, and for each of these we can do constructor dot, and then we can get a bunch of information like the parameter count, the amount of parameters that are in the constructor, the name of the constructor, the declaring class, which is just, you know, this one right here, parameter types, exception types, modifiers, a bunch of information. So let's try printing out some of this information so we can see what we got here. So we'll do s out constructor name, and so we'll do constructor dot get name. There we go. And oh yeah, let's run this so we can see what we have up here and also what we have here now. So let's run this and see what we get. There we go. So it says class name me.codysimpson.dog, interface false, array false, constructor name me.codysimpson.dog, constructor name is me.codysimpson.dog, just because we have two constructors here which are both dog, right? There we go. Pretty simple, but that's not very useful information. Let's try seeing if we can grab some more information from this. Before we do that though, let's make a simple thing here. New line, and then we'll say constructors. There we go, just to divide it a little bit for orderliness. And so let's see here. Let's try printing out the parameters of the constructor. We can do that. So we'll say s out params, and then we'll do that. So how do we get the params? We can do constructor.get parameters, and that obviously returns the params. There we go. So actually, if you look closely here, you can do get parameter count also, so you can determine how many parameters are in the constructor that we're working with here. So first, let's do constructor.get parameter count, and if it's equal to 0, then we know it's a no argument constructor, so there's nothing to print out, right? So we'll say no, oops, spit, what the heck? No arg, I can't type, no arg constructor. I keep saying constructor, it's just, I like saying it like that because the ending here, but it's constructor, whatever. So if it's not 0 arguments, then we obviously have some stuff to print out. So we can have a parameter array, parameters, is equal to constructor.get parameters, and this obviously returns all the parameters. So it returns an array of parameter objects that represents all the parameters to the underlying executable represented by this object. Returns an array of length 0 if the executable has no parameters. The parameters of the underlying executable do not necessarily have unique names or names that are legal identifiers of the Java programming language. Alright, cool. Alright, so now that we have, well, first before I continue here, let me show you, obviously there's a pattern here. There's a object reference for every single element of a class, which, you know, makes perfect sense because we're deconstructing a class at runtime and then storing these elements in references, and then we can grab information from them. So yeah, hopefully this all just makes sense so far. It's just a pattern, and we're deconstructing a class, so yeah. Anyway, so parameter array, parameters. So now we can do another loop here. So parameters. So for each of these parameters, let's do s out parameter. Let's see what information we can get. Parameter dot, we can do get name like always. So that's the parameter name, and then a space, and then plus parameter dot. Let's see what else we can get. Oh, we can get the type. That's information that we should have. So the parameter name and the type, that's pretty much all we need, I think, for a parameter. Yeah, that makes perfect sense. So what this will do, just to recap, it's going to get a class reference of a dog, and then it's going to get an array of all the constructors of that class, and then it's going to loop through those constructors, and then it's going to get the parameters of that constructor if there are parameters, and then it's going to print out each parameter along with its type. Okay, so let's see what happens. Let's run this. There we go. So it says class name dog, interface false, array false, constructors, constructor name me.codysimpson.dog, parameters no arg constructor, just because as you can see here we have a no arg constructor. And then second, we have constructor name dog, parameters arg0 is class java.lang.string, which is the type, and then arg1 integer is, and that you can see right here. So string name integer age. There we go. Pretty cool. So yep, there we go. So now we're breaking down a class step by step and getting the information from it, which is really cool. So let's see what else we can grab. Let's grab the methods of this class. So all the methods that we have here. Let's see how we can do that. So down here, let's do dog class dot, and we can do get methods. All right, so we have two major methods we can use to grab the methods here. We can do get methods, or we can do get declared methods. So get methods here returns every single public method of this class that we're working with here. Even the methods that were inherited by any superclasses that we're extending from, or anything like that. But this get declares methods method that we have here returns an array containing method objects reflecting all the declared methods of the class, including the private methods. So it shows everything, including the hidden methods of the class. But it only shows the methods that you're declaring in the class itself, not anything inherited. So it's only going to show these 4 methods here, not anything inherited by the object class, because of course every object implicitly inherits from the object class, if you don't remember. But yeah, let me show you an example so you can see solidified what this actually looks like. So let's try the get methods method first. So that returns a method array. So method methods is equal to dog class dot get methods. There we go, import method. Okay, so now let's loop through it. So for I integer I is equal to 0, I is less than methods dot length I plus plus. All right, so now let's print out the method. So we'll say something like method number, and then like I, so like method number, and we'll do I plus 1. Oops, I plus 1. So that'll say method number 1 starting from the first one, and then we can actually print out the method itself. So method number 1 plus methods I, so grab the method from the array dot, and then we can get the information from the method object that we have here. So get name, or yeah, let's do get name before we do the return type. So let's see what this looks like before we continue. And boom, so here we go. So now we get all of the methods. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So these are all of the methods of the class, including all of the inherited ones. But let me rephrase, not all of the methods of the class. Again, these are only the public methods of the class. So if we did have any private methods, it would not show up here. So let me show you that. So public, or private, void, kill, or yeah, just kill. Yeah, there we go. So now let's run this and see if that shows up there. Yeah, so as you can see, kill does not show up. It only shows the public methods of the class, including the methods that were inherited. So just public. Okay, so hopefully that makes sense. So let's print out some other information before we show how to do the other one. So methods I, and we can do get return type, and this returns, what does it return? It returns a class reference. So methods I return type dot get name. So that shows the return type of the method. And then let's put the method name. So methods I dot get name, and then what else? So we want to do the parameters of the method, right? Because that's another important element of a method if it has parameters. So we'll do methods. The methods I dot get parameters, as you can see here. So get parameters, and that returns a parameter array like we saw before. So let's just call arrays dot toString, and that will print out the array easily for us. So let's see what this looks like. Let's try it out. There we go. So now we get all of the methods down here. Method number 1, java.lang.string get name, and it has no parameter list, as you can see right here. So no parameter list, good. And so method number 2, void set name, and then it has the parameter java.lang string argument 0, and so on. So it prints all the important information. But one thing we are missing though is the access modifiers of it. So like in this case, public. So let's see if we can print that information. Let's put that right here in the front. So we'll do methods I dot get modifiers. There we go. So modifiers it should give us the modifier. So it says returns the Java language modifiers for the executable represented by this object. So let's see what that returns. Okay, let's run this now. Okay, what the heck is that? So of course it's not very useful to us at the moment as a number, so we can print it out as a string as we would normally see it, just by doing modifiers dot, or what is it, modifier? Yeah, dot toString. There we go. So we can pass in that number that was provided from get modifiers to modifier dot toString, and that should print out the modifier that we need. So let's see. There we go. So now we get the modifiers. So public void, public integer, public final, public boolean, public native integer, public final native, public final native, public final native. So these are the inherited methods at the end, of course. There we go. So that's how you get the modifiers of a class that you're reflecting or using reflection upon. Pretty cool. But let me show you how to do the get declared methods method. So get declared methods, and obviously that returns the declared methods, which represent all of the methods that you declared within the class alone. And that includes also, like I said before, all of the private and hidden methods that you would normally not see with the other one. So method array declared methods equals .class.get declared methods, and we just need to make sure that we change this. So let me copy this and change this to declared methods. There we go. So now that should print out all the information that we need. Let's try it out. All right. Let's put a space in between so we know where it starts and where it begins or whatever. I just said the same thing twice, didn't I? Okay, let's try it out now. There we go. So now we got a space. So method number 1, public java.lang.string get name, public void set name, public void set age, public integer get age, and then private void kill. There we go. So we got a private method now, and as you can see, all of the inherited methods are no longer listed as well. So this is just an easy way to get all of the methods of a class, even the private ones. So if you think about it, this, right? So normally whenever you have a class that has private members, you cannot access them programmatically. You cannot access them using the program without using reflection. So let me give you an example here. So if we go right here, this dog class does have a private kill method, right? This means that we cannot call kill. It's not possible. So if you can imagine that you've imported a library, or even if you're using your own code and you want to use private methods or access private fields even, you can use reflection to do so. So think about the possibilities in that case, right? You can use any of the private stuff using the get declared methods method if you have a class reference of a class. So hopefully that makes sense. Yeah, so just another example of how powerful this might be for your programs. Okay, so the final thing I want to show you is how to get fields. And by fields, I just mean these things here, the fields. So print the fields. And so how do we get the fields? I'm sure you can guess by now, right? There's a pattern. So dog_class.get, and you can get the fields. There we go. So get fields and returns a fields array. So fields or field array. Field array fields is equal to dog_class.get fields. There we go. All right, great. And let's try looping through this. So we'll do for fields. And so let's just print out some basic information on each of these fields, like their access modifier, their return type, and then their name. So do modifiers.toString, modifier.toString, field.get modifiers plus, and then the name. Or no, we want the return type now. So field.get return type, or actually not return type, I mean type, you know what I mean, right? So field.get type dot get name, and then the final space is the name of the actual field itself. So field.get name, and let's see what this looks like. Oops, get name. There we go. So let's try this out now. And there we go, nothing printed out. Why is that? Well, because the get fields method that we're using here only returns the public fields of this class that we're reflecting. It only returns the public ones, and these are both private, so it's not going to return anything. So let's make a public field here just to show you. So test, and let's try printing this out again, or running this again. And there we go. So now we get public java.lang.string test, but it doesn't print out the other ones because they're private, like I said. So how do we get all of the fields, even if they're private? So let's try this out. So get declared fields, just like we do with methods. So with methods, we do get declared methods to get all of the private and internal methods of a class. So this is how you get all of the private and internal fields of a class. So get declared fields. So let's try this out now, and it should print out everything. There we go. So now we get name, name, age, and then test. There we go. So we get all three of the class. And yeah, that's pretty much it. That's all I'm going to show you for this episode. This is a basic introduction to Java reflection. So now you should be able to access the internal information of classes, interfaces, and arrays. I didn't show you interfaces and arrays, but it's the same concept. I'm sure you can figure it out. This is how you access those things internally within your code dynamically. And by dynamically, I mean at runtime. So you can grab information from something that you're working with at runtime without knowing what it is beforehand, right? So if I was to change this dog class here, if I was to remove this and I was to rerun the code, obviously it would still work. So that's what I mean by dynamic pretty much. No matter, even if I change the code of the class, it's still going to work because it's grabbing the information on the fly as we're running the program during runtime. So hopefully that makes sense. But yeah, if you have any questions about this reflection concept, then please let me know. I'm going to have some other episodes on reflection in the future, like how to invoke constructors, how to invoke methods using reflection, and then some other important stuff. So please stay tuned for that and let me know if you do want to see that other stuff. So yeah, and besides that, I'll leave the code for this episode in the description below, so make sure you check it out and you can bookmark it for future use for the future. And like I said before, I'll leave some resources in the description below so you can check it out if you're interested in some more information that you can use to understand this concept more deeply. And also, I'll leave a link to our Discord community so you can get involved there, hang out with us, ask for help if you have any questions, or if you're stuck on something, you can ask for help and somebody can help you, or just get some new friends. And finally, you can also hit the join button below this video if you want to support me. You can join this channel as a member for as low as 99 cents a month, $5, or $10. So yeah, if you want to support me, then click that join button. You can become a member, and it comes with some cool perks like early access to all of my new videos, a cool rank on my Discord server, and also you get to see yourself on the screen like you see right now. So thanks to all of you who have supported me so far, and thanks to all of you who are watching my video. I appreciate you as well, of course. And that's it. So if you like this video, leave a like. If you want to see more, subscribe, and peace.